Okay, welcome to the exercise in the king demand curve, which you'll see in Oligopoly. So the headline here is Oligopoly and king demand curve. So I've just made a quick graph of the king demand curve over here and put in some key points down here. So the king demand curve stems from what is called an asymmetric competitor reaction, or asymmetric competitor behavior. That is what you see here. That is why you get the kink. It's because of that behavior. I'll return to that in just a moment. So that will lead to what is also called sticky prices. That the price is sticky, they can't change or they won't change. They can change, but normally they won't. There has to be a great difference or great change in marginal cost for the prices to change. Let's return to that also. So this is just at the beginning here at the video. I just want to outline what the exercises are all about. So now let's look at the exercise, right? So it says a baker produces bread sold to supermarket chains in Denmark. So what you want to do at the exam is quickly identify the problem, because you have a big book, so there's a lot of different kinds of problems. So what you want to know is this about the sticky prices? Is this about price differentiation? Or is this about production, or a whole another subject? So the challenge first and foremost is finding out which box does this exercise fit in. And I'll teach you this at the course also. So I'll go through the exercises and tell you how do we recognize this problem. So at the exam, of course, it'll have like a headline saying oligopoly, right? So you'll have to see that yourself. So the first sentence, we don't get a hint there. It's just talking about bread, and then we get the variable cost function. Then it says the baker has found out that the maximum amount of boxes he can sell is 28,000 boxes. Okay, that will be the intersection with the horizontal axis. So if it says the maximum amount, that is Q max, right? So if you put that in here, that will be Q max. At his current price of 120 kroner, he can sell 12,000 units. So we get the current price right now. The price elasticity of demand at that price, at a price increase, is estimated to be -2. That means if we are at 120 at price, if we raise our price by 1%, the quantity demanded will fall by 2%. That is what it says. Okay? The price elasticity of demand at a price decrease is not -2%. So it is different. That can only be if the demand has a kink. So if the change when we increase the price and the change when we decrease the price is different. See here and here. Here we can see that if we increase the price, we get a larger change in quantity compared to a decrease in price where we get a smaller change in quantity. So if they say that, if they write at the exam that the slope will be different, they can write the slope will be different, or they write that the change in percentages is different. Then you know that is the telltale sign of the king demand curve model. And then you move into this problem and you do as I do in this problem. So what you want to look out for is a sentence that says something about if I raise the price, I get one reaction or one slope, and if I lower the price, I get another reaction or another slope or another elasticity, thus differences, right? So that is what the kink is all about. So this is where I identify the model. Then we see that at our current price of 120 kroner, it is from there that we get different reactions, thus telling us that the kink is at 120 kroner. So we actually get the kink. So that must be 120. And it says at 12,000 boxes. So that'll give us 12,000 boxes. So now we get the kink. That is a very relevant information because that gives us actually a point on both functions, right? We get a point on this function up here and that one down there. So let's look at now what information we have. We have 2 points on the lower p function down here. Let's just call it p2. And this one up here, we can call that p1. We got the point here, but we also got another information. We got the information of the elasticity of demand. It said that if we increase the price, the quantity would fall by 2% if we increase the price by 1%. Thus, the price elasticity of demand moving upward is -2. That is all we need to derive the P functions and from them the marginal revenue functions. And this is what it's all about here in this exercise, right? So the first question is question A, determine the demand function and the marginal revenue function. So let's look at them here. So what do we know about P1? Let's start by that. So P1, we know a point on the curve or the function, and we know an elasticity. So we know that we have this point, 12,000, and when the price is 120, we know the elasticity is -2. So this is an information set from which we are supposed to derive a linear function. Maybe some of you have heard about this compendium I've written in Managerial Economics. Unfortunately, it is in Danish, but all the concepts are in English. So it's only the text that is in Danish. In this book, there's like a chapter 6, where from this matrix, all the information from your book, from your textbook, from your Managerial Economics book, from your syllabus, is put in here about deriving linear equations. And I'll upload this chapter to your personal profile at aspiri.dk, so you have this with you when solving the exam, even though you don't have my book. So I'll give you this chapter for free, right? So if you don't understand Danish, don't worry, because if you, for example, look at the methods, they're all written in math, right? It's math. It shows you in math what to do, which equations you need to substitute in numbers, and you know, math is like a universal language, right? So everyone understands it. Just follow the numbers. There are methods here. There are examples. So in my experience, even though you don't speak Scandinavian, I have a lot of Spanish students, Italian students. They can use this. They just follow the numbers. So that's why I've given it to you. I can, of course, recommend the book if you do speak Scandinavian. It's the most sold book at CBS, actually. It sums up your whole book. So just make sure if you buy it, not like if you buy a used version, just make sure it's the 4th edition, because the 3rd edition is like an old book from 2009, I think. And that was a whole other syllabus for you. So the 3rd edition doesn't fit your current syllabus. Only the 4th edition does. But you can also buy this 4th edition on the used book market if you want that. Just make sure it's the 4th edition, right? So what I want to say to you is that I'm giving you this chapter. And now I'm making a reference to that chapter, to that method. So of course you can write the methods into Excel and do the calculations there. I'll just put it up on the board here. And as you may notice, I've written Excel here. And that's because in this exercise, I will also show you the graph, show you some solutions using the Excel sheet I've uploaded to your personal profile at aspiri.dk. And that is because sometimes it's easier for me to understand using a board like this. But some of you would find it more easy to understand if you see the graph in Excel, if you see some of the calculations in Excel. So to satisfy all of you, I've done both. So in a lot of these exercises I go through, I've done it here at the board explaining it, and I've also done it in Excel. So then I hope you're all happy. So either way, if you prefer the one or the other, everyone is happy. I hope so, even though. So let's look at this information set. So if you use the compendium, right, then it says, if you have a point and a price with a belonging elasticity, you use this method, this matrix here. I have a point and a price with a belonging elasticity. It says use method 11 or 12. In this case, let's just turn to page 83. Then it says here at 83, use method 12 if the p-values are the same. And what is the p-values? This is the p-value from the elasticity and the p-value from the point. So if these p-values are the same, we should use method 12. If they were different, we should use method 11. So of course, if you were told that at a price of 150, we get another elasticity, then we were supposed to use method 11. So it's difficult to remember all methods, right? There's actually not a lot of students know that, but there's a lot of combinations of how to derive linear equation. There's actually 1, 2, 3, 4, 5, 6, 7, 8, 9 unique ways of deriving a linear equation. I put them all in here. Just find the correct one at the exam, solve it either by hand in Word or using Excel, doesn't matter, as long as you use the correct method. So I hope you'll do that. So let's look at the case here. So here it's method 12. And method 12 is at page 84 in the book. And that's what I'll use here. First and foremost, we get the slope. So the slope will be equal to price divided by quantity times elasticity. So if you haven't got the book right now, just write the formula down. I've taken this formula directly from the compendium. It's the traditional elasticity formula from your syllabus, rewritten, rearranged. So it's not like a formula that I have invented. It's the normal elasticity formula that we have rearranged, right? So the price here is 120 divided by quantity, which was 12,000, times elasticity, which is -2, giving us a slope of -0.005. So alpha means slope of the function, beta means intercept. So what we're going to find now is that intercept up there. So where the function intersects with the vertical axis. So from there we use the normal function, which is p minus alpha times q. This is the normal function for deriving the intercept in a linear function where you know a point and a slope right there. So it says 120 minus 0.005 times 12,000, which gives 180. So our P1 is minus 0.5 Q plus 180. So this is our P function. Now we know it starts in 180. Deriving the MR function from the P function, you can do two things. You can first multiply by Q, price times quantity gives you total revenue. Then you can differentiate the total revenue. Total revenue differentiated gives us marginal revenue. Perhaps you've taken one of my earlier courses where you know that when P is a linear function, MR will give you a linear function, but with twice the slope. So here I just multiply the slope by 2, but you could also do it the difficult way of first multiplying by Q and then differentiating. That's up to you. So down here, we get minus 0.01 Q plus 180. So this is our marginal revenue 1. So now we're finished with the first one with P1. Then we move on to P2. So in P2, we still got the point of 12,120, so that is the same. But here we also have another point of 28,000.0. So remember, the p-value is 0 with the intersections with the horizontal axis. So here we get another point, 28,000.0, and from that we can use method 10. You've actually seen method 10 before at high school and so on and so forth. So deriving a linear equation from 2 points, that should not be like whole news for you. So let me just write it up. I call it method 10 in the compendium. And it's on page 82, method 10. So first, we find the slope. We find that by subtracting the y values, y2 minus y1 divided by x2 minus x1. But in this case, y is p and q is x. So I actually write p2 minus p1 divided by q2 minus q1. So this formula, instead of p and q, x and y, you should have seen that before many times at high school and so on and so forth. Putting in the numbers here, I say 0 minus 120 divided by 28,000 minus 12,000. If I write that up, it'll give us minus 0.0075, which is the slope then. The constant, I use the same formula as before, P minus alpha times Q, which would then be 120 minus 0.0075 times 12,000. So there's a multiplication there. So substituting that in, I get 210. So then I can put up my P2, which is 0.0075 Q plus 210, and MR2, which would be twice the slope of P2, minus 0.015 Q plus 210. And then we get the correct answer, the P2 and the MR2 at this exam. So, looking now at the exercise, you will see that I've used some formulas. The formulas, of course, refer to the methods. Here's a formula for deriving slope. Here's another formula for deriving slope. But we use the same formula for deriving beta. So, if you want to do an Excel sheet that can calculate this for you, you just put in the numbers saying, for example, if I get this type of information set in the future, I'll just substitute the new numbers in, and then the Excel sheet, you do like a formula for this one, calculates itself like that and like that. So put in the blue formulas in your Excel sheet if you want to solve it in that way. And then you have like a sketch at, you know, how to do it if that comes at the exam. Also, it gives you full points to do the calculation in Excel. It's just about you opening a sheet, typing in the formulas, making sure you get the same result as I do, and just call it like information set. You control the sheet. When I have a point and a price with the belonging elasticity, I use this formula sheet. If I have 2 points, I use another formula sheet. Then you can derive these. If you don't want to do it with a calculator by hand, you can do that also. So looking at this question now, it says determine the demand function and MR function. Demand and MR. I've not illustrated the MR function yet. I'll do that in the next question. So in the next question, question B, where we're supposed to optimize profits and here marginal contribution margin, I'll do a good graph of it. I'll make a new graph where I substitute in the MR function and the MC function also. And I've also shown it in Excel for you if you prefer that. So watch in the next video how we optimize the contribution margin and finding out what should the baker do in this problem.